Hi, let's learn electric dipole. First, the definition is an electric dipole consists of two equal and opposite point charges plus q and negative q separated by a distance d. That means two equal and opposite charges are represented by plus q and a negative q. Both charges have equal magnitude and the two charges are separated by a small distance 2a. So this is a diagram which represents electric dipole. Electric dipole means two equal and opposite charges separated by a very small distance. Next, the one term related to electric dipole is dipole moment. Dipole moment is represented by the letter P. It's a vector quantity and it is defined as P equal to 2a, 2a, that is the distance between two charges, and the magnitude of one of the charges. So dipole moment is the product of 2a and q. 2a is the distance between two charges and q represent magnitude of one of the charges. So this is the expression for dipole moment P equal to 2aq. And here q is the magnitude of the charge and 2a is the displacement vector from negative charge to positive charge. That means the distance between two charges. And the direction of dipole moment is from negative charge to positive charge. The direction of dipole moment is always from negative to positive charge. So we can represent dipole moment like this. So this is the direction of dipole moment. The direction is always from negative to positive charge. Let's see the unit of dipole moment. Dipole moment unit is coulomb meter. As the unit of charge is coulomb and the separation between two charges meter, the unit of dipole moment is coulomb meter. And dipole moment gives a measure of the strength and orientation of the dipole in an electric field. Next, let's see the expression for the torque acting on an electric dipole placed in uniform field. So this is the diagram. Here, these parallel lines represent uniform electric field. These are the parallel lines. Each parallel line represent uniform electric field, and this A, B. These are the two charges, negative Q, positive Q, placed at the positions A and B. These two equal and opposite charges separated by a distance 2a. So this is the electric dipole, and it makes an angle theta with the uniform magnetic field. And this is a perpendicular distance from the electric field to one end of the dipole. And you can see this F represent the force acted on one end of the dipole when it is placed in a uniform electric field. So the force acting on positive charge is F is equal to QE. So force is the product of charge and electric field. The same way you can see at the position A, when negative Q is placed there, an equal and opposite force is acted. So that is F is equal to negative QE. So at the position B, the force acting is F is equal to QE, and at the negative charge force acting is F is equal to negative QE. So we can say at the position A and B, two equal and opposite forces acted upon it. And this vector P, this is the direction of dipole moment. This is always from negative charge to positive charge. So this represents dipole moment P, and this E represents our uniform electric field. Hope it's clear to you. Let's study the definition of electric dipole placed in uniform magnetic field. So hope you can see the figure. This is the figure. So because of the two equal and opposite forces acting at the two ends of the dipole, a torque is experienced by the dipole. So the dipole will rotate until it becomes parallel to electric field. You can see here F is equal to negative QE. At the positive charge, F is equal to QE. So these two equal and opposite forces acted upon the two ends constitute a torque. Therefore, this dipole will rotate until this dipole becomes parallel to the electric field. So let's write the equation of torque. Torque is denoted by tau, and the expression for torque is force into perpendicular distance. Expression for torque is force into perpendicular distance. The force equation we can understand from here. F is equal to QE. It is a product of magnitude of charge and electric field into this BC represent the perpendicular distance. So let's write perpendicular distance as BC. So let's find out sine theta from here. So sine theta equal to opposite side by hypotenuse. The opposite side is BC, hypotenuse side is AB. So BC by AB is what? This is the separation between two positive charges that is represented by 2A. So BC by 2A. From that, what is the equation of BC? BC is equal to 2A sine theta. 2A sine theta. So let's substitute this value here. So it is QE into 2A sine theta. QE into 2A sine theta. Let's rearrange this. Let me write 2A first. 2A and this Q next. What is remaining? Electric field and sine theta. So E sine theta. So 2AQ that is a product of separation of charges and magnitude of one of the charge represented the dipole moment. So let's write instead of 2AQ P, then remaining terms P E sine theta. P E sine theta. So tau is equal to P E sine theta. Let's write its vector form. Vector form. We should represent each letter by vector and exclude the angle term, that is sine theta. So torque is equal to P cross E. So this is the vector form of torque acted on the dipole placed in an electric field. So here first we wrote the torque expression, force into perpendicular distance, that is equal to QE into perpendicular distance is this. Perpendicular distance is this BC, and from this triangle we find out sine theta. Sine theta is BC by AB, and BC by AB is separation between two charges, that is 2A. From that BC is equal to 2A sine theta. So here we substitute instead of BC as 2A sine theta, then rearrange the 2A and Q right together, 2AQ into E sine theta. Therefore, torque equal to P E sine theta. So this is the required expression for the torque, and in vector form we can write as torque equal to P cross E. So this is the required expression. So let's see some cases. That is the maximum torque acting on the dipole. The maximum torque acting on the dipole when theta equal to 90 degree. When theta equal to 90 degree. So let's write the equation torque equal to PE sine theta. So that is equal to PE sine 90. Sine 90 is 1. So the answer is P. So this is the maximum value of torque acting on the dipole. Let's see stable equilibrium condition. Stable equilibrium. stable equilibrium when theta equal to 0 degree. Then use the same expression, tau equal to PE sin theta. So PE sin theta is 0 degree. So PE sin 0 is 0. So PE cross 0 is 0. So when torque equal to 0 degree, we can say that dipole is in stable equilibrium. Let's see the next case, unstable equilibrium. Unstable equilibrium occurs when theta equal to 180 degree. Theta equal to 180 degree. Therefore, torque equation tau equal to PE sin theta equal to PE into 180 sin 180. So as you know, sin 180 is 0. Therefore, P cross 0 equal to 0. So this is a case for unstable equilibrium when theta equal to 180 degree. Okay. Hope you understood. If you are not understanding, rewind the video. So here we derive the expression for the torque acting on an electric dipole placed in uniform electric field. Let me tell you what will happen if electric dipole placed in non-uniform electric field. When it is placed in non-uniform electric field, it exhibits both translational and rotational motion. Thank you.